Hello everyone, I am Kiran Kumar, your physics lecturer. Today's topic is angle of friction. Welcome to my channel Nature of Physics. See, this is the rough horizontal surface. A block of mass m and downward direction is mg acting, weight of the body, and normal reaction is perpendicular to the surface. And F is the applied force from left side to right side, and opposite direction frictional force is developed, that is taken as F. Now the resultant of normal reaction and limiting friction is taken as Fr, is the resultant of normal reaction and limiting friction. Now this making an angle phi, that is angle of friction. The resultant of normal reaction and frictional force making an angle phi with the normal reaction is called angle of friction. Simply, the resultant making an angle with the normal reaction is called angle of friction. So now tan phi which is equal to opposite by adjacent side. Opposite is frictional force. So F divided by adjacent side is normal reaction. So frictional force is directly proportional to the normal reaction. Frictional force is equal to mu into n, where mu is coefficient of friction. Now the value is replaced in the above equation. Tan phi, which is equal to mu into n divided by n, where n get cancelled. Now tan phi is equal to mu. See, if the body is at a rest position, then static friction takes place. If body at rest, nothing but here static friction takes place, that is tan phi s, which is equal to mu into s. So here phi s is the angle of friction for static friction, and here mu s is the coefficient of static friction, Next, we can discuss if the body is in slide. So if body slide on the surface, so then we can take here tan phi, which is equal to mu, so phi k and mu k. Why? So the body is in motion. That's why here kinetic friction or dynamic friction will takes place. Here mu k is the coefficient of kinetic friction and phi k is the angle of friction of the kinetic friction. Then just a second, I will clean the board. Now a resultant force I am going to find. See, from the diagram, resultant force So diagonal square is equal side square plus side square. Fr square, which is equal to f square plus n square. Fr is equal root over f square plus n square. And here conditions we can take. If phi s greater than to the phi k and mu s is greater than to mu k. So the coefficient of static friction is greater than to the coefficient of kinetic friction. Okay, and angle of friction of static friction is greater than to the angle of friction of the kinetic friction. Now, so here I am replacing static friction because of body at rest conditions. So now this is taken as Fs. So Fs value is Fs, which is equal to mu s into n. So Fr, which is equal to root over mu s square n square plus n square. Next, Fr, which is equal to n square root of get cancel, and remaining value is mu s square plus 1, but mu s is equal to tan phi s. So Fr, which is equal to n into root over tan square phi s plus 1. But one thing here, tan square phi s plus 1, which is equal to secant square phi. Then the resultant equation here, Fr, which is equal to n root over secant square phi into s. This get cancel. Okay, so then just a second. Continuation here, we can write Fr, which is equal to n into secant phi into s. So Fr, which is equal to mg into secant phi into s, because of n is equal to mg. And one more equation, Fr, which is equal to mg root over, this is tan square phi s plus 1. Just n is equal to mg is replaced. These are the very useful relations for the mains and NEET examination. So this is the angle of friction and their relations. Thank you. I will